In this video, ladies and gentlemen, we are going to start looking into area of similar polygons. In our previous videos, we talked about corresponding parts of similar polygons. We set up some basic proportions in terms of their side lengths and the corresponding side lengths more specifically. We then also discussed perimeters of similar polygons, and we said the perimeter ratio is equal to the corresponding side length ratio, which both ended up equaling the scale factor. So in this video, we're going to be looking at area of similar polygons now, because if two polygons are similar, then the ratio of their areas is equal to the squares of the ratios of the corresponding side lengths. So let's talk about this, guys. If you remember in the previous video, I asked you a question. Perimeter is in what types of units? And it's just linear units, because all we do is add the side lengths together. But think about how we write area units. Area units finishes in feet squared, inches squared, yards squared, meters squared, whatever the case is, units squared. So, with that being said, I can't compare area, which is in square units, to linear units. And so what we see here is that the area of the new is to the area of the old, just as the side squared is to the side squared. So super important that we compare squared units to squared units, linear units to linear units, and then at some point when we get to volume, cubic units to cubic units as well too. So let's look at an example of how we can put this into some practice. So it wants to know what the area of triangle DEF is given that ABC is similar to DEF. So what do we know? Well, I know for sure that the area is to the area. So area of triangle ABC is to the area of triangle DEF. And that will be just as a side length, all right? And I'm given information about AB and I'm given information about DE, so I'm going to use those two. Just as the side length of ABC is to its corresponding side length of DEF. But be careful, it's not just AB being 10, it's the length squared. It's the length squared of DE. And again, why? Because area is in units squared. So the area of ABC is given to us at 36. We don't know the area of DEF, so I'm going to call that X. That's what it wants us to know in the end. And I have AB as 10, but it's not just 10 we're going to put into our proportion to be 10 squared. And DE is 5, but again, we're not going to put 5 in, we're going to put 5 squared in because it is units being squared. So really, I end up setting myself a proportion where I have 36 over x is equal to 100 over 25. 25 goes into 25 once, into 100, 4 times. And so we get 4x equals 36. And then when we divide through by 4x, we get that 36 divided by 4, of course, ends up being 9. And so the area of DEF actually is 9 centimeters squared. And there's how we can utilize proportions to find area of similar figures. Don't forget to square the linear units.